Right now, the server running your company's software might contain a library you have never heard of, written by volunteers, embedded in hundreds of other libraries, doing something as mundane as writing log files. That library had a critical flaw for years that nobody noticed. When it was finally found in December 2021, the CISA director called it the worst cybersecurity vulnerability she had seen in her entire career. It existed in billions of devices. Exploitation required a single line of text sent to any input field. You could trigger it by typing in a game's chat box. Log4j is a Java-based logging library, a piece of software that records events, errors, and information to log files. It is maintained by the Apache Software Foundation, a nonprofit. Logging is so fundamental that Log4j was embedded in thousands of Java applications without developers necessarily knowing it was there. It existed inside enterprise software, from Cisco, VMware, IBM, and Oracle. It was inside Minecraft's Java Edition server. It was inside government systems, hospital software, financial platforms, and industrial control systems. The attack surface was essentially the entire internet. The vulnerability, CVE 2021-44228, named Log4Shell, was discovered by a security researcher at Alibaba Cloud and disclosed to Apache on November 24, 2021. Apache released a patch on December 9th. Within hours, proof-of-concept exploit code was publicly available on GitHub. Within 24 hours, active exploitation was observed. Within 72 hours, over 800,000 exploit attempts were logged. Nation-state actors from Iran, China, North Korea, and Russia began exploiting it simultaneously, an extremely rare convergence of advanced threats on the same vulnerability at the same time. The technical mechanism is elegant in its simplicity. Log4j has a feature called JNDI, Java Naming and Directory Interface Lookup Functionality. When Log4j logs a string, it checks whether the string contains a JNDI lookup pattern like $, open brace, JND : all dap. If it does, Log4j fetches and executes code from the URL specified in the string. An attacker who can get a string logged by a vulnerable system through a username field, a search box, an HTTP header, anything, can trigger remote code execution. No authentication required. No interaction from the target. The exploitation methods were staggeringly diverse. Security researchers documented the exploit string being hidden inside HTTP user, agent headers, URL parameters, username fields, email addresses, and, most memorably, a Minecraft username. A player changed their in-game name to a JNDI exploit string. The Minecraft server logged it. The server executed the attacker's code. The attack worked because every input that eventually gets logged is a potential injection point. In an application that logs comprehensively, as good applications should, nearly every user input was exploitable. The remediation challenge was compounded by the depth of the dependency problem. Organizations that quickly scanned their direct dependencies found Log4j and patched it. Then they discovered the libraries. Those libraries depended on also contained Log4j, nested 3, 4, 5 levels deep in the software supply chain. Some vendors took months to release patches because they had to identify Log4j in products they had shipped years earlier. Some products were no longer actively maintained at all. The long tail of vulnerable systems persisted for over a year after disclosure. Log4Shell accelerated a conversation that the security industry had been avoiding. Open source software is infrastructure, and infrastructure needs resources. Log4j was maintained by volunteers. The software ran inside critical systems at the world's largest companies, which generated billions of dollars in value from it. Almost none of them contributed back. After Log4Shell, the Linux Foundation, Google, and major tech companies launched the Open Source Security Foundation with significant funding specifically to audit and improve the security of critical open source dependencies. Software Bill of Materials, SBOM, became a mandatory topic after Log4Shell. An SBOM is a formal list of every component and dependency in a piece of software. When Log4Shell was disclosed, most organizations had no idea whether or how deeply the library was embedded in their stack. A complete, current SBOM would have allowed those organizations to immediately identify exposure. The White House Executive Order on Cybersecurity, issued in May 2021 before Log4Shell, but refined in response to it, now requires SBOMs for software sold to the U.S. federal government. The Log4Shell crisis also validated WAF rules and network-level mitigations as a first line of defense while patches are deployed. Security vendors released WAF signatures within hours that could detect and block JNDI lookup strings in HTTP traffic. Organizations with well-configured web application firewalls were able to buy time while patching. Those without WAFs faced raw exposure. The incident reinforced that defense in depth, layered controls that each independently reduce risk, is not paranoia. It is the minimum viable architecture for anything public-facing. One library, maintained by volunteers, embedded in billions of devices. One feature nobody was supposed to abuse. The entire internet had 72 hours between patch release and mass exploitation. Log4Shell is the clearest possible illustration of how supply chain risk works. The vulnerability was not in your code, but it was in your product. If you want to understand another attack that exploited the software supply chain at scale, our video on the Movie It attack, 10 day, 100 million people, covers how a single file transfer tool compromised 2,000 organizations simultaneously.